Hello everyone. In this video I want to show you how to analyze a very simple beam. As you can see, we have two supports and point load with intensity of P uh, is applied. You see, length of the beam is also L, and everything here is about parameters. You see, in place of support A we have two reactions. One is A sub y, that is the reaction in vertical direction, and we also have A sub x, that is the reaction in horizontal direction. In place of support B, however, we just have one reaction, that is by, that is in y direction. So we look for these support reactions AX, AY, and BY. We can use three uh, equilibrium equations. Sigma m should be 0, sigma f in y direction should be 0, and also sigma f in x direction should be 0. So let's start with moments. We take moments at point A because it has two reactions, and if we take moment at this point we can remove them from our uh, equation. So we can say that sigma m at point A is equal to 0, and also this is the positive direction for our moments. So we can say that b sub y times L minus P times L divided by 2 should be 0. You see, point load is here. Its distance from the support is L divided by 2. So its moment is P times L divided by 2. If we solve this for By, it gives us By equal to P divided by 2. This is the reaction of support B in y direction. So we use this equation. Let's go to the next one. We can say that sigma f in y direction should be 0, and also this is the positive direction for fy. So we can say that b sub y minus a sub y, plus a sub y minus p should be 0. We have by, we found by here, so we can say that p divided by 2 plus a sub y minus p should be 0. If we solve this for ay, it gives us that ay is p divided by 2. So ay and ay and by would be exactly the same. We have the vertical reactions of these two supports, but we do not have any horizontal force in this question. So if we use the third equation, and if we say sigma fx should be 0, so we can say that ax is simply 0 because we do not have any force in x direction. So for now we have all the support reactions. So we should draw the shear force diagram and bending moments diagram of bending moments. So let's get rid of all these things. Okay, let's move this beam to another place that we can analyze it. Good. So for this beam we know that ay is p divided by 2 and by is the same, P divided by 2. The first necessary thing is that we should draw our guidelines. They are very important in drawing those shear force and moment diagrams. Let's say this is for shear and this is for moment. Okay, you see here the support reaction is P divided by 2, so it simply increases the shear force here, and it increases the same as the support reaction. It would be P divided by 2, but it remains constant until it reaches the P force that decreases the shear by value of P. So we can say that this distance is the same as P. So here the shear force would be minus P divided by 2. It would be negative. And then again it remains constant until again the support reaction increase it to 0, from a negative value to 0. So this distance would be P divided by 2. That is the same as our support reaction. Now this is the shear force diagram, and it helps us to find the bending moments diagram. Look at this part of the graph. If we say, for example, this is area 1, and let's calculate area 1. Area 1 would be P divided by 2 times L divided by 2. So it would be PL over 4. So this is 4. So we can say that this part of the graph increases the bending moment to PL over 4. That would be a point here. So we can say that this is the bending moment diagram that we have plotted using the first part of the shear force diagram. In the second part, you see area is the same, but it's negative. So say area 2 it's minus P over 2 times L over 2. That would be minus PL over 4. So it means the bending moments decreases to 0. So initially it increased because of the positive shear force, and then it decreased because of the negative shear forces that existed in our beam. So you see this part of the bending moment diagram is induced by negative shear force, and then this part was induced by positive shear forces. So we have both the positive and negative moments and positive and negative shear forces in our beam, and we simply solved this beam and found its support reactions, and we plotted the shear force and moments diagrams. I hope you like this video, and please subscribe that you can follow my videos about statics and structural analysis. Thank you so much.